Welcome, Geometry iPad Initiative students. This is Mr. Lane here to do another exciting lesson. This one's going to be a little bit of a review from Algebra 1. Kind of a tough little section though from your Algebra 1. Hopefully you've got this already, but we're going to brush up on it just in case. It's over systems of equations, and this is the elimination method that we're going to focus on. There's going to be some problems that come up in the next couple of sections that we're going to have to use this in order to solve some of the questions. So we're just going to go ahead and get a little review in and make sure that you know it. So make sure you get question number 5 answered in your half a page notes, and also make sure you get your summary and email that to me as usual. And let's get started. So the first thing I've done here is just made a checklist for elimination. So let's read through it real quick. We're going to rewrite the system to align the like terms, which just means that we're going to have the x's in one column, the y's in another column, and then after the equals, we're going to have our constants over here. So let's move on down. We're going to then eliminate one of the variables. We have to obtain opposites. So either like on the 2 or on the x, I could have a 2 and then a -2, so the x's would add out, or I could do the same on the y's. But we must eliminate one of the variables so that we can solve for the other variable. Now once we solve for that remaining variable, we can plug it back into the original equation in order to figure out the other variable that we need. And then if you wanted to add a little number 5 here, you can always plug it back into both the original equations to make sure that it checks out. And I think I've got an example, and I think I've just walked it out here on the right hand side. So notice that we do not have our variables stacked on one another, so it looks like my first step to align them, I've got to switch the x and the y's place in the first equation, because I usually like to get the x's in the first column and then the y's in the second column, and then the constants over here. Notice when we do that the y's are already opposites, because one of them's a -2 and the other one's a +2. So we've already got our opposites. So when I add them together, then what we want is those opposites to add out. So it looks like I would have 1x plus 5x's would give me 6x's is equal to -18. Divide both sides by the 6 to get rid of it, and x would equal -3. So we've figured out what one of the variables is. Now we need to plug it back into one of the original equations to figure out what y is. So I've chose the first equation up here, x minus 2y equals -19. I'm going to take that -3 and I'm going to substitute it right into the place of the x there, making it a -3 now. So I have a -3 minus 2y equals -19. So I add the 3 to the other side, giving me a -16. I still have the -2y left on the left hand side. I got to divide by the -2, so y would equal 8. Alright. Plug back into the originals. We just want to do that to check it out to make sure that we've got the right solutions, and notice that they both check out, so we know that we have it correct. Alright, let's move on. I've got one example here that we just want to see which one of these two methods is correct. So let's look at it real quick here. Looks like they rewrote this with a -3 on the right hand side and the x and y on the left hand side. And then it looks like we need opposites, so I think they're minusing or multiplying this whole equation, the second equation, by -1. When they do that, notice that the y's would add out because they would now be negatives. I'm just going to write over the top of this. I'll have a -3x x minus y, and then that would be a negative 5. So in order to add these out, I would have a negative 2x's left, but right there looks like it should be a negative 8. So this one is incorrect, which would mean that this one has the negative 8, which would be correct. So the blue is the correct one. Alright, now we can apply the systems of equations to geometry problems here. Notice that I got a diagram here. The little red in there just means that that angle is 90 degrees. So this adjacent angle looks like it's going to be supplementary with that. Just means this plus the 90 will equal 180. And also this one looks to be a linear pair formed with that 90, so this plus the 90 would equal the 180. So let's just start by writing those two things real quick. So I'm going to have 6x minus 2y's plus 90 equals 180. And then I'm going to have 3x plus 2y equal, oops, should have had a plus there, plus 90 equals 180. So if I subtracted off of both of these the 90 right here to the other side, then I could shorten both of these equations a little bit. So let's subtract the 90, subtract the 90, and now I'm going to have the equation. I'm going to write it right down here. 6x minus 2y equals 90 degrees. I'm going to have the equation here when I subtract the 90 from both sides. I'll have 3x's plus 2y's equals 90. So now I've got them already aligned where the x's are in one column, the y's are in another column, and the constants are in a column. Notice that the y's already has opposites. So if I just add these equations together, then they'll add out. I'll have 9x's, when I add those together, equals 180. So if I divide by 9 on both sides, I would have x equals 20. Now I got to plug that back into one of the two original ones so that I can find what y is. So let's go up to the top one here. Actually, let's do the bottom one. Looks a little bit easier. So I'm going to use this one right here, and I'm going to go 3 times my 20 because I'm plugging it in for the x now, plus 2y's equals 90. So that would be 60 when I multiply the 3 times the 20 plus the 2y's equals 90. So minus the 60 looks to be 30 left on this side, and the 60 would subtract off over here. So I have 2y equals 30. So if I divide by 2, see if I can extend the page a little bit, then y would be 15. So the ordered pair 20, 15 would be the solution. Alright, looks like we got another one set up here that we'll need to figure out a couple of equations and solve. So let's get right into it. I notice that well, this is a linear pair right here, so I'm going to go ahead and write this angle measure in. So what plus 72 would equal 180? Looks to me like it should be 108 degrees right here. Now, hopefully you realize that vertical angles are always congruent. So I'm just going to put that 5x's plus 2y's will equal that 108. And I'm also going to put that 2x's plus 4y's will equal the 72. Okay. So now I don't have opposites yet, so I'm going to have to multiply one or both of these by something, but I notice that the y's would probably be the easiest to multiply here because I've got 4 here, and if I multiply the 2 by -2, I would have opposites. So I'm just going to write out here that I'm multiplying this top one by -2, so I'll have a -10x minus 4y's equals a negative, looks to be what, 216. So now I can add them, and my y's are going to add out when I add them now. So it looks like I'll have negative 8x's equals my negative 216. So I'm going to have to divide by the -8 to finish solving for x here. So let's see, 8 will go into 21 2 times, and that's going to leave me with a 56, which will be a 7. So it looks like my x is 27. I've got to plug that back into one of the two originals. Again, I think the bottom one looks to be a little bit easier to use, so I'm going to use it again. So I'm going to have a 2x, or 2 times, I'm going to go ahead and plug in the 27 for the x. Plus my 4y's equals my 72. So I'm going to multiply the 2 times the 27, which will be 54, plus my 4y equals 72. So I need to subtract the 54 over. Subtract 54. And let's see, 72 minus 54 would be 18. Let's see, let's just borrow real quick. Yep, should be 18 equals 4y. So when I divide by 4, not going to turn out nice and neat on this one. Looks like it's going to be y is equal to 9/2. And that won't reduce any further, so I'm just going to leave it like that. So my x is 27, and my y is 9/2. Right. So I've got one here. If you wanted to practice, you could pause the screen and practice it out. Make sure that you get it right. And I think that's actually going to wrap us up. So Mr. Lane signing off from OHS High School. We'll see you next time.